Dear students, welcome back to Basics 2 of Pressure. Now, before I start the class, I just would like to share with you a small story. Fox and cat, fox and cat, fox and cat. Simple, very interesting laughing. A fox was boasting to a cat of its clever devices for escaping its enemies. Suppose some hunters are coming. The fox was telling that, I can escape in several ways. The cat was slowly listening. The cat told, I have only one small trick. No, the fox told, I have a whole bag of tricks. 100 ways of escaping I know from my enemies. The fox was so proud, so arrogant. In the meanwhile, 4 or 5 hunters were approaching both cat and the fox. The cat knows only one. Just at that moment, as soon as the cat heard the cry of the hunters towards approaching them, he saw, and the cat immediately screamed up a tree and hid herself in the leaves. This is my plan, the cat said. The cat asked affectionately, admiringly, what not. Fox, what are you going to do? The fox thought of first one way, then another way, then another way, then another way. And while the fox was debating the ways it has 100 tricks, the hunters came nearer and nearer, and at last the fox was caught up by the hunters. So, what is the moral? What is the good thing in this small fox and cat story is better one safe way than 100 on which you cannot reckon. So this is the fox and cat story of today's class. Now let us go straight into basic atmospheric pressure patterns. Basic atmospheric pressure patterns. There are various smaller pressure systems, identified in a small area, so daily, weekly, on the surface of the earth or on the surface of the sea or on both. Number 1, basic atmospheric pressure patterns. Number 1, low pressure systems or cyclones. The second one is high pressure systems or anticyclones. What are the low pressure systems or cyclones? When the isobars are circular or elliptical in shape and the pressure is lowest at the center, such a system is called low, L-O-W, low, or depression, D-E-P-R-E-S-S-I-O-N, or cyclone, C-Y-C-L-O-N-A. When isobars are circular or elliptical in shape, the pressure is lowest at the center, which is called as low, L-O-W, low, or depression, D-E-P-R-E-S-S-I-O-N, or cyclone. This is what is cyclone. A line of low pressure is called a trough, T-R-O-U-G-H. When the isobars are incomplete, we call it as trough, T-R-O-U-G-H. The word cyclone is derived from Greek word cyclos, meaning the coils of a snake. Cyclone is derived from Greek word cyclos, meaning the coils of a snake. In India, cyclones occur during the, northeast monsoon season. October ending, November, December, middle. These are called as low pressure system or cyclones. Now, the diameter of a cyclone usually ranges from few hundreds to 2000 kilometers. What exactly does it mean? If you are starting from southern India, going to northern India, the cyclone effect you may find in 500 kilometers area, 1000 kilometers area. After that, you will not find cyclone effect Okay, so what exactly does it mean? The diameter of the cyclone ranges from few hundreds, 200, 500, 700 to a maximum 200 kilometers. A cyclone will never occupy the whole of India, the whole of Asia, small areas only. Of course, floods are the results of cyclones. This is what we call it as a low pressure system or cyclones. What are the high pressure systems or anticyclones? When isobars are circular, elliptical in shape, and the pressure is highest at the center, such a system is called high, H-I-G-H, high or anticyclone. When the isobars are elliptical rather than circular, the system is called ridge or wedge, R-I-D-G-E, ridge or wedge. In low pressure systems, okay, low pressure systems are also called as low depression cyclone. Okay, here high pressure systems or anticyclones are also called as high or anticyclones when the isobars are circular, elliptical in shape, and the pressure is highest at the center. Okay, of course, when the isobars are elliptical rather than circular, then the system is called a ridge or wedge. There we call it as a trough. Incomplete isobars are known as trough. Here the elliptical isobars are called as ridge or wedge. Now, what are the differences between cyclones and anticyclones? Lowest pressure at the center, and it increases towards the outer rim gradually in the cyclone. In the anticyclones, highest pressure at the center and it decreases towards the outer rim gradually. In cyclones, relative humidity increases towards the center and bring cloudy weather. In anticyclones, relative humidity decreases and clouds are dissipated, okay, giving fair or clear weather. Variety of clouds lie at different heights in the cyclone. Little clouds with cool dry air are usually associated with anticyclones. Highest rainfall occurs because of the cyclones. Rainfall is almost negligible due to anticyclones because their center is high pressure. The wind velocity increases from outer rim to the center in case of cyclones. The wind velocities are much lesser than cyclones. The cyclones move in anti-clockwise direction in the northern hemisphere and clockwise in southern hemisphere. The anticyclones move in clockwise in northern hemisphere and anti-clockwise in southern hemisphere. So, cyclones are usually low pressure, anticyclones are usually high pressure areas. Humidity, rainfall, clouds, water, everything you find in cyclones. In anticyclones, no much of relative humidity, no variety of clouds, no rainfall. You find in anticyclone. As far as wind velocity, it increases from outer rim to the center in cyclones. Wind velocities are much lesser than cyclones in anticyclones. Cyclones move in anti-clockwise direction in the northern hemisphere and clockwise direction in the hemisphere, exactly reverse in case of anticyclones. Now, after trying to understand what are the basic pressure patterns, low pressure systems are cyclones, high pressure systems are anticyclones, and the differences between cyclones and anticyclones, we try to understand factors affecting pressure of a place. The atmospheric pressure is very highly, extremely highly complicated and varies widely on the globe. The atmospheric pressure is highly complicated. There are regions of high and low pressure formed on the earth as a result of the factors like temperature of the air, altitude, humidity in air, revolution of the earth, difference in rate of insolation, that is incoming solar radiation. These are the factors. Temperature of air, altitude, humidity in air, revolution of the earth and difference in rate of insolation. These are the factors affecting pressure of a place. Now, let us try to understand very interesting, daily useful, very useful to raising a crop. Variations in pressure of air and weather. There is a strong relation, absolutely strong relation between pressure and weather. Okay, what is that? Variations in air pressure and weather. Now, in just 1 minute, I tell you the most essence of pressure. High values of air pressure produce clear and stable weather. What is it? High values of air pressure produce clear and stable weather. When you go out of this classroom, if you are finding clear weather, that means sun is there, no clouds, then your area where you are standing is the pressure is high as compared to 10, 15, 20 kilometers away from you. Exactly reverse. Low values of air pressure produce cloudy and unstable weather. So, when you go out of this classroom and see some clouds are there, slight drizzling is occurring, your area where you are standing is low pressure area as compared to an area maybe 40, 50 or 60 kilometers away from you. This is the relation between the pressure and weather. Whenever rain is occurring, there is a low pressure. Whenever clear weather is, there is a high pressure. A continuously rising air pressure is an indication of clear and stable weather. A steadily falling air pressure is an indication of cloudy and unstable weather. So, based on this, you can take so many operations day to day on the crops. Okay, temperature, pressure. When pressure is increasing, safely you can go for chemical spray. When pressure is slowly decreasing, stop, because it is going to be cloudy weather. So, this is how you can infer the variations in air pressure and weather. So far in this class, we tried to understand basic atmospheric pressure patterns. Number 1, low pressure system or cyclone. Number 2, high pressure systems or anticyclones, and the differences between cyclones and anticyclones. Cyclones are lowest pressure at the center, anticyclones are highest pressure at the center. In the cyclones, relative humidity, wind velocity, variety of clouds, water are high. Anticyclones, relative humidity, clouds, rainfall are less. They move in anti-clockwise direction in northern hemisphere cyclones and clockwise in southern hemisphere. Okay, exactly reverse in anticyclones. Then factors affecting the pressure of a place we discussed. What are the factors? Temperature of air, altitude, humidity in air, or revolution of the earth. And the fifth one is the difference in the rate of insolation. Now, just a couple of minutes back we discussed variations in air pressure and weather. High values of air pressure produce clear and stable weather. Low values of air pressure produce cloudy and unstable weather. Now, we just go to last but one basic pressure terminology in this class, and the final thing is units of measurement of pressure. Only that much is there. Basic pressure terminology. What is pressure? What is atmospheric pressure? What is standard atmospheric pressure? Pressure is defined as force per unit area, just like meteorology. Meteorology is the study of the science of atmosphere. Just simple 4 words like that. Pressure is force per unit area. Atmospheric pressure, the pressure exerted by a column of air with a cross-sectional area of say 1 square inch or square centimeter extending from the earth's surface to the outermost or uppermost boundary of the atmosphere. So, atmospheric pressure means the pressure exerted by a column of air over a square centimeter area extending from the earth to the uppermost boundary of the atmosphere, that is troposphere, stratosphere, mesosphere, ionosphere, exosphere, up to exosphere. If you presume a column in 1 square centimeter area, how much is the pressure exerted is called as standard. Of course, it is known as atmospheric pressure. What is the standard atmospheric pressure? Atmospheric pressure at 15 degrees centigrade and 45 degrees latitude is known as standard atmospheric pressure. Pressure is force per unit area. Atmospheric pressure is the pressure exerted by a column of air over a square centimeter area which is extending from surface of the earth to the outermost boundary layer. Now, when atmospheric pressure is measured at 15 degrees centigrade, 45 degrees latitude, 45 degrees latitude, it is standard atmospheric pressure. Now, what are the values? 1013.25 millibars or 29.92 inches or 760 millimeters of mercury at the sea level. It is considered as the standard atmospheric pressure. Now, the basic pressure terminology are pressure, atmospheric pressure, standard atmospheric pressure. Pressure is defined as force per unit area. Atmospheric pressure is the pressure exerted by a column of air over a square centimeter area extending from the earth's surface to the uppermost boundary of the atmosphere. The atmospheric pressure at 15 degrees centigrade, 15 degrees centigrade and 45 degrees latitude is standard atmospheric pressure or standard normal pressure. It is 1013.25 millibars or 29.92 inches or 760 millibars. The last component of the class is units of measurement. Okay, pressure is measured in bars, millibars, kilopascals, lbs per square inch, dynes per square centimeter. So these are the things which I would like to discuss. Thanking you very much for your patient hearing of the very interesting basics too of pressure. May God bless you. Thank you very much.